Alright, so this lesson is called Angle Sum of a Polygon, and the learning goal is that we're going to find a formula, and we'll probably use this formula for angle sum of any size polygon. Now, many of you are probably going, what is a polygon? We've actually been working with them for a while. I'll give you an example of one. This one. What do we call it? Triangle. Okay, and it's a polygon of three sides. 1, 2, 3. I'll give you an example of another one. This is a quadrilateral because it has 4 sides. So we call this a quadrilateral. All right, and there are special quadrilaterals as well, isn't there? There's like a square. That doesn't look like a square. There's a square. We know the square because they have all equal sides. We have rectangles. Hopefully this one ends up nice. We have rectangles. They're special types of quadrilaterals. And then we can even go further. And that's what we're going to do in the next slide. So here I've drawn some quadrilaterals, okay? Some polygons. And I have written it down. So what I want you to do is number 3, we'll start with 3. We can't have a polygon less than 3 sides. 4, 5, 6, 7, 8, 9. So what I want you to do is go to Google, so pause this video, go to Google and find out the names of all the different types of polygons. So what a 5-sided polygon is, what a 6-sided polygon is, and so on. Okay. Once you've done that, come back to. We'll just do it here. So does anybody know a 5-sided polygon? It's a pentagon. Has anyone seen in America, the military officers is called the Pentagon? And do you know why it's called the Pentagon? Because it's the shape of a pentagon, which is a 5-sided shape. And then a 6-sided one is a hexagon. And then the 7-sided shape is a heptagon. Sometimes we call it a septicon, right? 8-sided shape is an octagon, so please write these in your books. And a 9-sided shape is a nonagon. Okay. Now, what's really interesting is that there's a pattern of their angle sum of each one of them. I'll ask you, what is the angle sum of a triangle? And you'll say 180 degrees. And you'll be exactly correct. And then you go, what's the angle sum of a quadrilateral? And you go 360 degrees. And you also would be exactly correct. And I want to show you something here. Look at this. 180 degrees is this triangle. Now, if I start from just one vertex, I can't go anywhere else, and I try a line until I make a triangle. I'm going to make a straight line there. Okay. I can't go and make a triangle anywhere else because I need to go to a vertex. So I need to go to another corner. Okay. Is there any other corner I can go to make another triangle? No, I can't. Alright, so 2 triangles. Well, triangles are 180 degrees. 180 degrees. 180 plus 180, that's 360 degrees. We might be onto something here. Let's try this. So we start from one vertex, and we need to go to one of the others. Okay. We can only do straight lines. See how many triangles we have. I can't do any more. So each one of these must be 180 degrees. 180 plus 180, 180. Oh, that's 540 degrees. So what's happening is that as the number goes up, we're adding 180 degrees. Because we're adding an extra triangle. Let's try it one more time with this hexagon. So all the vertexes, I'm going to put them in different colors. We've got to start from 1, it doesn't matter which one, and then we'll go boom, boom, boom. Oh, how many triangles? 180. And notice this. This has 1 triangle, this has 2, this has 3, this has 4. So we've got to add another 180 degrees for a hexagon. So 80 plus 40 is 120. So we're at 620. So that's going to be 720 degrees. Oh, that's interesting. So we've found the pattern. But can we find a rule that fits every single one of them? See if you can. Have a think about it. So obviously the next one's going to be 900. 180 plus that is going to be 1,800. And then we've got 180 plus that, which is 1,260. And then so on. So we can find off any number. We just keep adding on 180 degrees. But I don't want to do that. I don't want to keep adding 180 degrees. I know the pattern. I want a formula that can do it for me. Have you thought about what it might be? It's actually this. I'll put it above here. It says angle sum of polygon is actually n minus 2 times 180, where n is number of sides. Okay, so let's go angle sum. Alright, so how many sides in a triangle? There's 3. So if I put 3 minus 2, so let's do that. 3 minus 2. What's 3 minus 2? That's just 1. 1 times 180. Oh, that's just 180, and that's what we get there. See, it works. I want you to try it for a few different ones that you might get out there. I'm going to use it for an example in the next slide. So if you haven't written all this down, make sure you copy it down. Here we have a polygon. It goes, find the angle sum of the following polygon. Well, first of all, we need to know how many sides there is. 1, 2, 3, 4, 5, 6. It's a 6-sided polygon. It actually has a name, 6-sided. It's a hexagon. All right. So 6-sided polygon is a hexagon. What's the angle sum of a hexagon? Well, we've got a formula. It's n, this is the angle sum, n minus 2 times 180 degrees. What was n? N is the number of sides. How many sides is there? 6. So 6 minus 2, what's that? It's going to be 4. 4 times 180. What's 4 times 180? 720. Yeah. And now I'll put an extra bit here. And hence find x. Alright, let's find x then. I'm going to put a line through the middle here. X equals, we've got to always start with what the final answer is, 720 minus all the other information. Minus 130 minus 100 minus 100 minus 115. And what does this symbol mean? 90. So I'm going to do that. Minus 130 minus 100 minus 110 minus 115. And I can't forget this one, which is 90. Alright, I'm going to put that in my calculator. Hopefully you've done this already. And we should get the answer. I've got an answer of 175 degrees. Alright, hopefully that helps you out. Just one more thing. A regular sided polygon is a polygon with all sides the same and all angles the same. So an example of that would be an equilateral triangle or a square. And then as we go up, we don't know. Anyway, hope that helps. Peace out.